A quiet frustration sits inside almost every student's life. Books open, notes spread across the desk, hours pass slowly, pages are read again and again, lines are highlighted, words are repeated in the mind. It feels like progress, it feels like learning, but then a strange moment arrives a few days later. The exam paper appears, a question is written in front of you, and suddenly the mind goes blank. The information that once felt clear and familiar has vanished. All those hours of studying seem to disappear into silence. This is not a rare experience. It happens to millions of students around the world. Long nights of studying, short memories of what was studied, and the cycle repeats again and again. This problem is so common that many people start believing something is wrong with their brain. They start thinking their memory is weak. They compare themselves with others who seem to remember everything easily. Some even begin to believe that intelligence is something you are simply born with. Either you have it or you do not. But modern research in psychology and neuroscience tells a very different story. The truth is surprising. In many cases, the problem is not your memory at all. The real problem is the way most people study. Schools rarely teach how memory actually works. Students are given information, they are given books, they are given deadlines, but they are rarely taught the science of learning itself. And because of that, many students spend years using study methods that feel productive but secretly weaken memory instead of strengthening it. For decades, scientists have studied how the human brain stores and retrieves information. Universities across the world have run experiments with thousands of students. What they discovered shocked many educators. The study habits used by most students are among the least effective ways to learn. Reading notes again and again feels comfortable. Highlighting text feels satisfying. Rewriting notes feels organized. These actions create the powerful feeling that the brain is learning deeply. But inside the mind, something very different is happening. The brain is simply recognizing information, not remembering it. Recognition feels like understanding, but it fades quickly. When the book is closed and the notes disappear, the memory often disappears with them. Now here is where the story becomes interesting. While most students struggle with forgetting, a small group of learners consistently remember far more information with far less effort. These students are not studying twice as long. They are not reading the same chapter 10 times. In fact, many of them spend less time looking at their notes than the average student. Yet their memory is stronger, clearer, and longer lasting. Researchers began asking a simple question: what are these students doing differently? And the answer led to one of the most powerful discoveries in learning science. Hidden inside decades of research is a simple but incredibly powerful method that can dramatically improve how well you remember what you study. This method is used by top students, competitive exam champions, medical students, language learners, and even scientists who must remember huge amounts of information. What makes this method so powerful is not complexity. In fact, it is surprisingly simple, but it changes one critical thing about studying. Instead of focusing on putting information into the brain, it focuses on pulling information out of the brain. That small shift transforms the way memory is built. Scientists discovered that every time the brain struggles to recall information, the memory becomes stronger. The act of remembering is not just proof that learning happened. The act of remembering is actually part of the learning process itself. Each time you try to retrieve a piece of information, the brain rebuilds that memory. The neural connections that store it become stronger and easier to access in the future. It is similar to walking on a path through a forest. The first time the path is difficult to see, the ground is rough, and the direction is unclear. But every time someone walks that same path, the trail becomes clearer and easier to follow. Eventually, the path becomes obvious. Memory works in a very similar way. This discovery explains something many students have experienced without understanding it. Sometimes during a test, a difficult question forces the brain to search deeply for an answer. The mind struggles for a few moments, and suddenly the memory appears. That moment of struggle feels uncomfortable, but it actually strengthens the memory more than hours of passive reading. In other words, difficulty in remembering is not a sign of failure. It is often a sign that real learning is taking place. In this video, you will discover the most powerful way to remember what you study. You will learn why traditional study habits often fail. even when they feel productive. You will learn how the brain truly forms strong memories. And most importantly, you will learn a simple technique used by top learners around the world to remember information for much longer periods of time. By the end of this video, studying will no longer feel like pouring knowledge into a leaking bucket. Instead, you will understand how to train your brain to hold on to information in a much deeper and more reliable way. There is also an important reason to stay with this video until the end. Many people hear about powerful study techniques, but never fully understand how to apply them correctly. Small mistakes can reduce their effectiveness. Later in this video, you will see a simple system that anyone can use immediately after studying any topic. This system takes only a few minutes, yet it can dramatically increase how much information your brain keeps over time. Students who use this approach often discover that they remember more after one focused session than they used to remember after several hours of rereading notes. Another fascinating part of this story is that the brain itself seems designed for this method. The way neurons connect, strengthen, and reorganize information supports this style of learning far more than passive reading. Once you understand why this happens, studying begins to feel less like hard labor and more like training a powerful mental skill. The same brain that once struggled to remember simple details can become remarkably efficient at storing knowledge. By the time this video ends, the way you think about studying may completely change. The goal is not to study longer, the goal is to study smarter. The difference between those two approaches can save hundreds of hours of frustration over a lifetime of learning. Welcome to Feynman's Chalkboard, a place where we explore the ideas that help us understand how the world and the mind truly work. If you enjoy learning powerful concepts that change the way you think, make sure to subscribe to the channel and join us for more videos that turn complex ideas into clear understanding. Now let's begin uncovering the most powerful way to remember what you study. A pattern appears in the study habits of millions of students. The book opens, the chapter begins, lines are read slowly, important sentences are marked with a bright highlighter, key definitions are copied into a notebook, pages are reviewed again and again until they look familiar. At that moment, the brain feels calm, the information looks clear, it feels like learning is happening, but this feeling is often misleading. The brain is recognizing information, not remembering it. Recognition is easy, memory is different. When the same words appear again on the page, the brain says this looks familiar, and that familiarity creates the illusion of understanding. Yet the real test of learning comes when the page is gone, and the mind must produce the information on its own. Many students discover at that moment that familiarity disappears quickly. The words that once looked clear suddenly feel distant and difficult to recall. This pattern has been studied for many years. Researchers at major universities observed students while they prepared for exams. They noticed that the most common study methods were also the least effective. Reading notes repeatedly creates a sense of progress because the information becomes visually familiar. Highlighting creates a similar effect. The bright color draws attention and makes the brain feel organized. Rewriting notes can also feel productive because it keeps the hands busy and the mind engaged. Yet experiments repeatedly show that these methods produce surprisingly weak memory retention. Students often believe they understand the material deeply, but when they are asked to recall the ideas later without looking at their notes, much of the information disappears. This discovery surprised many educators. For decades, classrooms encouraged students to read carefully, underline key sentences, and review notes multiple times. These habits seemed logical. If exposure to information helps learning, then repeating that exposure should help even more. But the brain does not store information in such a simple way. The brain is not a container where knowledge is poured and stored permanently. It is a dynamic system that strengthens memories through effort and use. Information becomes stable when the brain is forced to retrieve it, not when it passively receives it. To understand this difference, it helps to think about how the brain builds memories. Inside the brain are billions of neurons. These neurons communicate through electrical and chemical signals. When you learn something new, certain groups of neurons begin forming connections with each other. These connections represent the memory of that information. But in the early stages, those connections are weak and fragile. Without further activity, they fade quickly. The brain constantly filters information, keeping only what appears useful or important. If a piece of information is rarely used, the brain slowly reduces the strength of the connections that hold it. This is why simple reading often fails. When a student reads the same page again and again, the brain sees the information repeatedly but rarely needs to work for it. The answer is always visible on the page. The brain does not struggle to retrieve it because retrieval is unnecessary. As a result, the neural connections remain weak. The moment the book closes, the brain loses its easy access to the information and the memory fades. Something very different happens when the brain is forced to search for an answer. Suppose you close the book and try to remember what you just studied. At first, the mind hesitates. The information feels slightly out of reach. The brain begins scanning through related ideas, searching for the missing piece. During this search, the neurons connected to that memory become active. When the correct information finally appears, those neural connections grow stronger. The act of remembering reinforces the pathway that produced the memory. Scientists call this process retrieval. Retrieval is the act of pulling information out of memory rather than placing information into memory. It sounds simple, yet it changes the entire learning process. Each time the brain retrieves a memory, it strengthens the network of neurons that represent that information. The memory becomes easier to access in the future. Over time, repeated retrieval transforms fragile knowledge into durable knowledge. One of the most important discoveries in learning science is that retrieval itself improves memory. This idea may sound obvious, but for many years it was misunderstood. People believed that testing simply measured learning. A test was seen as a tool to evaluate what students already knew. But experiments revealed something unexpected. Testing does not only measure knowledge, it actively builds knowledge. Students who regularly test themselves remember far more information than students who only reread their notes. To understand why this happens, consider how the brain responds to effort. The brain is designed to strengthen pathways that are used frequently. When a memory is retrieved, the brain treats that memory as important because it has been needed again. As a result, the neural pathway becomes stronger. The next time the brain searches for the same information, the pathway is easier to follow. With enough retrieval attempts, the memory becomes stable and reliable. This leads to one of the most powerful learning methods known today. The method is called active recall. The idea behind active recall is simple. Instead of repeatedly reading information, you challenge your brain to produce the information without looking at it. The focus shifts from recognition to retrieval. The brain must search for the answer instead of simply seeing it. In practice, active recall begins right after studying a topic. A student reads a section of material and tries to understand the main ideas. Then the book closes. The notes disappear from view. At that moment, the real learning begins. The student asks simple questions. What did I just read? What were the main ideas? What were the key terms? How would I explain this idea to someone else? The brain begins searching for the answers. At first, the responses may be incomplete. Some details may be missing. That is normal. The important step is the attempt to remember. After trying to recall the information, the student opens the book again and checks what was correct and what was missing. This comparison reveals the gaps in understanding. The missing pieces stand out clearly. The student studies those parts again briefly. Then the process repeats. Close the book. Try to recall the ideas again. Each cycle strengthens the neural pathways connected to the information. Active recall works because it transforms learning from a passive activity into an active challenge. Instead of reading the same words over and over, the brain must rebuild the knowledge from memory. This rebuilding process strengthens the connections that store the information. Over time, the memory becomes easier and faster to retrieve. A helpful way to understand this process is through a simple analogy. Think of a narrow path through a forest. At first, the path is difficult to see. The ground is covered with leaves and small plants. Walking along this path requires careful attention, but each time someone walks along it, the plants are pushed aside. The soil becomes more visible. Eventually, the path becomes clear and easy to follow. Memory pathways inside the brain behave in a similar way. Each retrieval attempt clears the path between neurons. The connection becomes stronger and easier to travel. Another reason active recall is powerful is that it reveals what the brain does not yet know. When students reread notes, it is difficult to identify weak areas of understanding because everything appears familiar. But when the brain tries to recall information without help, missing pieces become obvious. These gaps guide further learning. The student can focus attention exactly where it is needed, instead of reviewing information that is already well understood. Many of the most successful students use variations of this method without always realizing the scientific explanation behind it. After studying a chapter, they test themselves with questions. Some write short summaries from memory. Others explain the idea aloud as if they were teaching a class. Each of these actions forces the brain to retrieve information rather than simply recognize it. Teaching is especially powerful. When you try to explain an idea clearly to another person, the brain must organize the information in a logical way. The explanation must connect different parts of the concept. During this process, the brain repeatedly retrieves pieces of information and links them together. This strengthens multiple neural pathways at the same time. The result is deeper understanding and longer-lasting memory. Students preparing for demanding exams often rely heavily on self-testing. Instead of rereading the same material many times, they practice recalling it through questions and problems. Each question forces the brain to retrieve the relevant information. Over time, the process becomes faster and more accurate. The student gains confidence because the knowledge is truly stored in memory rather than simply recognized on a page. A simple study system can bring these ideas together into a clear routine. The first step is to study a small portion of material. This may be a short section of a chapter or a single concept. The goal during this stage is basic understanding, not perfect memorization. The student reads carefully and identifies the main ideas. The second step begins immediately after reading. The book closes, the notes are set aside. The student then attempts to recall everything that was just studied. This recall can take several forms. Some students prefer to write down what they remember. Others speak the ideas aloud. Some create questions and answer them from memory. The method itself is flexible. The key requirement is that the information must come from memory rather than from the page. The third step is verification. After attempting recall, the student checks the original material. Any missing details become clear at this stage. The student reviews those details briefly and ensures they are understood. The fourth step is repetition. After some time has passed, memory strengthens when retrieval occurs multiple times across different moments. Returning to the information later forces the brain to rebuild the memory again. Each retrieval strengthens the neural pathway further. Over time, this cycle transforms learning. Instead of reading information again and again with little improvement in memory, the brain actively practices retrieving knowledge. Each retrieval attempt strengthens the memory network. The information becomes easier to access and more resistant to forgetting. Students who adopt this approach often notice a surprising change. Studying may feel slightly more challenging at first because the brain is being asked to work harder, but that challenge is exactly what strengthens memory. With practice, the process becomes natural. The brain becomes skilled at retrieving information quickly and accurately. The difference between passive reading and active recall is similar to the difference between watching someone ride a bicycle and learning to ride one yourself. Watching may create familiarity with the idea of cycling, but the body does not develop the balance and coordination required to ride. Only active practice builds the necessary skills. Memory works in much the same way. Only active retrieval builds strong and reliable knowledge. As students continue using this method, they begin to notice that information stays in memory for longer periods of time. Concepts that once disappeared after a few days remain clear for weeks or even months. This stability reduces the need for last-minute cramming before exams. Learning becomes more efficient because each study session produces lasting results. Another advantage appears when subjects become more complex. Advanced topics often require connecting many ideas together. When students rely only on reading, these connections remain weak. But when the brain repeatedly retrieves different pieces of information, it naturally begins linking them into larger networks. Understanding deepens because the knowledge is actively reconstructed rather than passively observed. This process reveals an important truth about learning. Memory is not simply about storing facts. It is about building networks of meaning inside the brain. Each time information is retrieved, those networks expand and strengthen. Over time, the brain becomes better at navigating them, finding connections, and applying knowledge to new problems. The most remarkable part of this method is its simplicity. No expensive tools are required. No complex technology is necessary. The essential change lies in shifting the focus of studying from reading to remembering. This shift activates the natural mechanisms the brain uses to strengthen memory. With consistent practice, the act of closing the book and recalling information becomes a normal part of studying. The brain begins expecting this challenge and responds by strengthening the neural pathways involved. What once felt difficult gradually becomes easier. Knowledge becomes more stable, and learning becomes far more effective. As this cycle continues through different subjects and topics, the brain develops a powerful habit of retrieval. Each study session becomes an opportunity not only to encounter information, but to train memory itself. Over time, this training builds a mind that remembers more clearly, understands more deeply, and learns more efficiently. Hours of studying often look impressive from the outside. A desk covered with books, pages filled with notes, long nights of reading and rereading the same chapters. Many students believe this is what serious learning looks like. Time becomes the measure of effort. The longer someone studies, the more they feel they must be learning. But the mind does not measure learning in hours. The brain measures learning in engagement. What truly matters is not how long your eyes stay on the page, but what your brain is doing with the information during that time. Real learning begins the moment the brain is challenged to remember. When the page disappears and the mind must rebuild the idea on its own, something powerful happens inside the brain. Neurons begin firing together, connections strengthen, weak memories become clearer. Each time you search your mind for an answer, the pathway to that knowledge becomes easier to travel. Slowly, the information stops feeling distant and starts feeling natural. What once required effort becomes something you can explain easily, recall quickly, and use confidently. This is the quiet secret behind strong memory. The brain grows stronger through effort, not comfort. Reading the same page repeatedly feels smooth and easy, but that ease often hides fragile understanding. Struggling to remember may feel harder in the moment, yet that effort is exactly what transforms information into lasting knowledge. Every attempt to recall is like strengthening a bridge between ideas inside the mind. The more often that bridge is used, the stronger it becomes. Over time, this simple shift changes the entire experience of studying. Instead of feeling like endless repetition, learning begins to feel like training the brain itself. Each question you ask your mind becomes an exercise. Each moment of recall becomes practice. And slowly, something remarkable begins to happen. Information stays longer, ideas connect more easily, concepts that once seemed difficult begin to feel simple and clear. This is why learning is not really about how long you study. It is about how your brain interacts with what you study. Passive reading fills time. Active remembering builds memory. The moment you stop only looking at information and start pulling it from your own mind, studying becomes far more powerful. What once felt like hard work begins to feel like progress. Knowledge was never meant to sit quietly on a page. It becomes meaningful when it lives inside the mind, ready to appear when you need it. Every student has the ability to build this kind of memory. It does not require extraordinary intelligence or special talent. It only requires understanding how the brain truly learns. So the next time you open a book, remember this simple shift. Read to understand, but close the book to remember. Let your mind search. Let it struggle for a moment. That effort is not a problem. That effort is the process of learning itself. If this idea changed the way you think about studying, then you are in the right place. On Feynman's chalkboard, we explore powerful ideas that help you understand the world, the mind, and the science behind learning itself. If you want to keep discovering smarter ways to think, learn, and grow, make sure you subscribe to the channel. And if you found this video useful, take a second to like it and share it with someone who studies hard. but still struggles to remember what they learn. Sometimes the smallest shift in understanding can completely transform the way a person learns for the rest of their life.